Hello and welcome to my KubeDOOM tutorial. The goal of this tutorial is to show you how to use tools like KubeDOOM, Prometheus, and Grafana together to monitor your Kubernetes environment while you introduce K8s using KubeDOOM. The definition of K8s engineering, ripped straight from Google, is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. What is KubeDOOM? KubeDOOM is a software that allows you to run Doom inside of a Docker container and connect to it from your VNC client. On the back end, it is able to monitor your Kubernetes environment and spawn enemies in the game that represent your Kubernetes pods. As you kill the enemies, the corresponding pod tied to the enemy terminates. This is a fun way to test resiliency in your application deployments. I'll be running through this tutorial on a virtual machine running Ubuntu 22.04. I have the following software installed on the virtual machine: VS Code for my IDE, Docker Desktop with Kubernetes enabled, kubectl, and Kind to build K8s clusters quickly. This tutorial assumes you have a basic understanding of Kubernetes and Docker. I do not stop to explain a lot of my commands, as I provide most of the documentation needed on the GitHub repository. It will also require a VNC viewer. In this demo, I am using Tiger VNC. If you have any questions, please leave a comment and I'll try my best to answer it. If you learned something from this video, please consider leaving a like. Now let's get started. Alright, so here we are on the Ubuntu virtual machine. We're going to double check a couple things here. We're going to make sure that we have Docker Desktop installed for whatever operating system you're running on. I'm just running Ubuntu, so this is Docker Desktop for Ubuntu. We have to make sure that we have Kubernetes installed after Docker engine is successfully running. So to do that, we could just go to Settings and Kubernetes and make sure it's enabled. Then after that, we can go out to GitHub and link to my GitHub repository of KubeDOOM Prometheus. And we're going to clone this down and follow the instructions in the README file. So to clone it down, we can go ahead and copy the SSH link, open up terminal, and I'm just going to go into my developer folder and run a git clone of the repository. Oh, having some technical difficulties. Alright, so all I had to do was specify the URL instead of the SSH. So now that we have this cloned down, we could cd into the new directory of KubeDOOM Prometheus. And my IDE of choice is VS Code, so that's what I have installed on this virtual machine. So I'm going to go ahead and open VS Code from here. Go ahead and trust those authors. So now you can see that we have all the files loaded up in our file tree to the left. Go ahead and open up a new terminal. And we could begin following the instructions here. So the first step that I'm going to do is skipping ahead a little bit, and we're going to go ahead and get the the Kind Kubernetes cluster up and running. So I'm going to scroll down to running KubeDOOM inside of Kubernetes, and I'm going to follow these instructions to install a Kubernetes cluster using Kind. Run this command here. It's going to install a Kubernetes cluster based off this kubeconfig.yaml file. It's going to spin up a control plane node and a worker node. Alright, well, that took about 30 seconds to finish up, but now that that's done, we could set our kubectl context by just copying this command here. And we could see that we got some information here, but there's one more thing we need to do. We need to apply our manifest files. So we can just easily do that by copying and pasting the command, and kubectl does everything for us. And we can confirm that by popping over to Docker desktop and checking out that we have a kind worker and kind control plane spun up. So now we can kind of follow things from the top here. So we'll want to build the Docker image first, and we could do that just by running this docker build command that's provided in the README. And we're gonna name the target KubeDOOM. This will take you a little bit longer. I've already got the image installed on my machine. Building it can take like 5 to 10 minutes depending on what machine you're building it on. But now that I have that image built, I can go ahead and open up a separate terminal here, and let's run this command. So if we break down this command a little bit, we can see that it's setting some permissions, setting a volume, but we're specifying a namespace here of default. So kubectl on the back end, this Docker container is going to be looking for the default namespace for Kubernetes deployments. So if we open up this terminal, we could see that it's not really outputting much information anymore. Game ticker's coming back with no information, and that's okay. It's just looking for deployments in the default namespace that we simply haven't deployed yet. So we could fix that. Here we can copy this kubectl apply command. This is gonna spin up a generic Nginx deployment for us with, we can modify the Nginx deployment here. So looking at the config, it should spin up 5 pods of Nginx for us. Nothing too crazy, but we can open up a separate terminal. And pull up our Docker run terminal from here. And let's go ahead and paste that kubectl. Whoops. I already see an issue. I'm going to need to be in the actual folder for this to work. And now we can paste that command. So with both terminals pulled up, we can apply it. It's created. We should see the game ticker over here respond with, yeah, see now it's picking up our newly created pods. And to confirm our pods are working, we can run the following kubectl command to check. And we can see there's 5 Nginx deployments, or pods, running. So that's cool. So let's check this out. We've got Docker and the Kubernetes cluster running. We've got the KubeDOOM application pointed towards our default namespace with 5 Nginx pods deployed in our default namespace. So now let's see if we could just connect to Doom over VNC. Well, according to the attaching VNC client documentation, we should be able to open up a VNC viewer and connect over localhost port 5901 and type in the password ID behold to log in. So I've downloaded Tiger VNC as my VNC viewer of choice for Ubuntu. If you're on Mac, you can use the default screen share application. I think you can even download Tiger VNC for Windows as well. So we're going to try 5901. So we're getting no connection, and I think I know why. I need to actually update this documentation, and we need to connect over port 5900. So by the time I upload this YouTube video, I should have this documentation updated to be 5900 instead. Let's make sure that's working. So now we're getting a password prompted instead of just a connection refused. So we'll type in ID behold, as the password, and check it out. We have Doom running in a Docker container. It's pretty responsive, so let's get a couple more things pulled up here. Over here, I would like to demonstrate these pods actually being killed. So I'm going to type a watch command so we can actively monitor. So we can do watch kubectl get pods in the namespace of default. And so this will refresh every 2 seconds and update the status of our pods. So I suck at Doom. So I've included some cheat codes for us so that way we can not have to worry about our skill and how much we suck. So I'm going to type in this cheat code to let me clip through walls, this cheat code to give me guns, and this cheat code to give me invincibility. So I should be able to just type that right into the Doom screen here. And I had a typo. No clipping on. Guns enabled. And God mode enabled. So let me pull up my terminals again. And I should be able to, switch to my gun here. And if we clip through this wall to our right, we should see our Kubernetes containers represented as Doom demons with the pod names above their heads. And if you watch this terminal up here, we should see the containers be destroyed as I kill these demons into game. Alright, that's enough of that. Alright, so that's cool. This is our first step into chaos engineering. We can kill Kubernetes containers by playing video games in Doom. But how do we represent this visually? How do we actually get metrics and monitoring on these containers? So in my GitHub repo, I've included a couple charts to deploy Grafana and Prometheus. We use Prometheus to scrape the metrics on our Kubernetes deployments. This gets stored in some sort of data source. In this example, the data source is just going to be Prometheus itself. And then we deploy Grafana, and we will build a dashboard in Grafana that will look at the Prometheus data source, and we'll be able to track metrics on our Kubernetes deployment. So we can actually kind of see what happens from a metric standpoint of when we actually kill our containers in Doom. So to do that, we can take a look at our manifests here. I've got a Grafana manifest and a Prometheus manifest. So to kick off these manifests, we can go ahead and check out the README. So deploying Prometheus, first we're going to create a new namespace called monitoring to keep our Prometheus and Grafana deployments inside the monitoring namespace so we don't accidentally kill them when we're killing our pods in other namespaces. So we can do that with a simple kubectl create namespace command. Namespace monitoring created. Now we could simply deploy the Prometheus manifest by running this kubectl apply command, and with the -n monitoring flag, we're going to deploy Prometheus strictly to the monitoring namespace. And we can see it's deployed. To confirm, we can run this kubectl get command to pull the Prometheus pods. And we can see there's a Prometheus deployment in the container creating status. So cool. And now it's running with an IP of 1.25. So here we go. In a separate terminal, run the below command to port forward, and you'll be able to access Prometheus on localhost 8080. So let's go ahead and try that. Within VS Code, I'm going to open up a new terminal, and I'm going to go ahead and run this kubectl port forward command. Oh, well. So, to fix this, we will go ahead and run the git pods again, or just copy this name. Replace the name in the example with the pod name from the previous git pods command that we ran. And you can see we're getting a successful port forward. So, according to this documentation, we can hit localhost 8080. And we can actually view our local deployment of Prometheus. So this is nice. If you don't know much about Prometheus, it scrapes your Kubernetes resources and stores the metrics in a data source that you can build upon and query at a later time. So I believe I could do doing this. Oh, and there we go. So then we can hit graph, and we can kind of see our stuff being graphed here. We're actually seeing data. These Nginx containers aren't being used, so their CPU usage is at like 0%. So, but you should be able to see the lines, and you can click down here to single out a single container if you want. So now we need to install Grafana, because Grafana is just a way easier client to build dashboards in. So let's follow the README steps again for deploying Grafana. We can switch back to the original terminal and deploy the Grafana YAML configuration with the kubectl apply command. Grafana is created, and another terminal lists the pod names and port forward from one of the pods. So we'll go ahead and start a third terminal, and let's go ahead and copy this git command. We can see we've got two Grafana pods and a Prometheus deployment here. This says to grab the name of one of the pods and put it in the port forward. So we'll go ahead and copy this. And we'll copy one of these Grafana pod names. And now Grafana should now be reachable on localhost port 3000. Let's check that out. And here is a local instance of Grafana. According to the documentation, we can log in with admin. Set a new password. Let's not save. And here is Grafana. So, first things first is we're going to have to reconfigure our data sources in Grafana. So if we follow the instructions, once we are logged in, you will need to go to the settings gear icon in the bottom left and edit data sources. So we can open up Grafana, go to settings, go to data sources. We can see that we have a Prometheus data source here. So let's go ahead and click on that. And we can see we have a URL specifying a Grafana resource. But if we come down here to save and test, we get an error saying that there's no such host on that specific URL. So what do we need to do? In the documentation, it states we need to change the Prometheus URL to something else, the Prometheus pod IP with 9090 as the port. And we can use the following command to get the IP address. So we'll go ahead and copy this command. Let's not mess with those two terminals and go back to our original one. And we'll see that our Prometheus deployment has an IP of 10.244.1.25. So we'll go ahead and copy that IP address, and we will go back to Prometheus, and this said to replace this URL with the Prometheus pod IP address over port 9090 instead of 8080. And we can go ahead and hit save and test, and now you can see that we have a working data source. So if we come over here though, you'll see that we have no dashboards when we try to search for dashboards. So we'll need to create our own dashboard essentially to monitor the Nginx pods as we kill them in Doom. So following the instructions even more, we'll build a Nginx dashboard example. So prior to this, we kind of skipped ahead and ran this command already to get our Kubernetes pods spun up so I could demonstrate them in Doom for you. But following this a little bit further, we can create a dashboard in Grafana to monitor the Nginx containers. To do this, we're going to open the localhost instance of Grafana and log in. We already set our data source to the Prometheus pod from the previous step, so we're good there. From the left-hand menu, we're going to create a new dashboard and add a panel. Select the panel's drop-down menu and select Inspect, then select Panel JSON. Here you'll be able to delete the current JSON and replace it with JSON from the Grafana folder, Grafana Nginx panel.json. So I pulled that up earlier. So under this Grafana folder, I've included an Nginx panel.json file. So this is actually the JSON that's going to be our configuration for the Grafana panel. And it just uses this Prometheus expression that I copy and pasted earlier. So I'm going to go ahead and copy this JSON just to my clipboard. I'm going to go to my local instance of Grafana and I'm going to create a new dashboard. So to do that, I'm going to check dashboards here to the left. I'm going to scroll down to new dashboard and I'm going to just click one of these, add a new panel. Sure, why not? I'm going to go back, and from this drop down menu for the panel title, you can hit this and go down to the more option. Oh, actually I'm wrong, it was the inspect option, and you'll see panel JSON. So when we open panel JSON, we'll get this nice side menu. It's already got a configuration in it, but we can come in here and edit this as much as we like. So let's go ahead and delete everything in here and copy the Nginx panel JSON that we copied from here. So it looks like I'm going to have to recopy this and paste and override everything in here with our own Nginx config. Let's go ahead and hit apply on that. You can see that this panel changes except for the panel title. So if we want to edit this panel title, we can just hit edit, change the title from the right, and change this to something like Nginx containers and hit apply. Now we don't see much because our containers haven't been up for a while, so we'll have to adjust our time here from last 6 hours to something like last 5 minutes. So here we can see that all of our containers haven't really done much. They've been spun up. Basically, they're not under load. If you had a deployment that was under load, you could use this to kind of monitor different CPU stats of it going up and down, blah, blah, blah. But for this example, I just wanted to show you a Grafana dashboard interface and what that looks like when we start introducing chaos engineering and destroying Kubernetes workers using something like KubeDOOM to do it. Just introducing chaos to your environment, breaking stuff, and seeing how well your application handles it. So let's break this all down. Let's tie this all together. So we've got Grafana and Prometheus scraping the deployments. We've got 5 Nginx pods stood up. We've got Doom running, able to recognize our Nginx pods, and we're able to kill them by playing Doom. How fun is that? So now I'm just going to shrink this so we can get everything all on one screen. I'll go ahead and minimize everything so there's not too much going on in the background besides what we need to see. I'm just going to readjust some screens here. Resize some stuff. So now we've got it all running. We've got Doom, a watch command going on our pods in the default namespace. We've got KubeDOOM actually running. And then we've got Grafana monitoring our Kubernetes deployments. So I'm going to go ahead and start a new game. And let's retype in those cheat codes. So I'm going to pull the documentation back up and see if I could type in the cheat codes real quick. There we go. Oh, my bad. There we go. Now we got everything pulled up. So I'm just gonna go play Doom for a minute, kill these demons, let them respawn as the Kubernetes containers spin back up, as they should. Alright, well this is cool. We've killed pods. Now, but let's see what Grafana's doing. So Grafana's not over here auto refreshing. So if we wanted to see what our charts are doing, we can come over here and just refresh, and we can see we've got some new data here, and we've got a whole bunch of new deployments added onto our chart. And this is because Grafana is picking up on all the pods we've killed and all the new pods that are spinning back up. So if you had applications under a workload actually using CPU, you can kind of get an idea of how it's handling when you just introduce chaos into the environment and start taking applications down. This is a super fun way to get your foot into chaos engineering and start testing the resiliency of your applications and how your environment withstands introducing chaos and basically the unknown. I'm not saying go out and convince your boss to let you run this in a production environment, but it is a fun exercise to do to demonstrate a metrics and monitoring stack, as long as just getting hands-on with Kubernetes in a fun way while using Doom to kill your Kubernetes workers. Hey guys, if you made it this far in the video, I just wanted to say thanks. Please consider liking and hitting the subscribe button. I'm going to keep trying to produce tech related and gaming related videos, so if that's what you're into, then stick around. Thanks.